Hello students, Assalamu Mualaikum. This is RKBA. In my today's video, I will discuss with you some topics from class 9-10 Higher Mathematics School and from the chapter 1. And we all know that the name of chapter 1 is Sets and Functions. In my previous Higher Mathematics video, I discussed with you about the definition of set. And the definition was like this: set is a well-defined and related collection of things or objects from the real world and the conceptual realm. After that, I discussed some types of set, such as universal set, subset, complement set, power set, etc. In my today's video, I will discuss with you two building and describing method of set, and they are roster method and rule method. After that, we will solve example from the chapter 1.1 example, and that is example 1. And finally, we will start our first activity from the chapter 1.1 example, Inshallah. So let's start our today's video. At first, what is roster method? This is very important for us to know about roster method before starting mathematics from chapter 1.1. The process of listing well-defined elements of a set in purpose of knowing exact elements from any kind of set is known as roster method. So it can be said that roster method is actually a method of describing exact elements of specific set. For example, if set A is equal to x such that x belongs to even numbers and x is greater than 0, less than 40, here even numbers are actually paired numbers. Then in roster method, the elements of set A will be 2, 4, 6, 8, 10, 12. Therefore, comma are being used to differentiate the elements of a set. There is another method of set which is known as builder method of set. The process of building a set by expressing type of related elements and specific range of those elements is known as rule method. So we can say rule method is actually building method of any set. For example, if set B is equal to 5, 7, 9, 11, 13, 15, which has been written in roster method, then this set can be written in rule method like this: B is equal to x such that x belongs to odd numbers and x is greater than or equal to 5, less than 70. Here, odd numbers are actually unpaired numbers. Besides, this rule method of set B obviously refers the type and range of all elements that belongs to set B. Now, we will solve example 1 from your textbook. The question of example 1 is given that u is equal to x such that x is an integer and x is greater than 0, less than or equal to 10. A is equal to x such that twice x greater than 7, and b is equal to x such that thrice x less than 20. Write down the elements of set A and A prime in roster method, set B and B prime in roster method. In this question, U is an universal set which contains the elements of positive integer. A and B, both sets are subsets of this universal set U. We have to solve the elements of set A prime, B prime in roster method in case of this universal set U. After that, we have to solve three statements whether these statements are true or false. First one is A prime is subset of B. Second one is B prime is subset of A, and third one is A is not subset of B. At first, we will solve the elements of set A and A prime. According to our question, we know that universal set contains positive integers which are located between 1 to 10. So we can say U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So U contains these 10 elements. Since we will solve the elements of set A, we have to notice set A given in our question. A is equal to x such that twice x greater than 7. Here x is obviously an integer and the result of multiplication 2 with x will have to greater than 7. Now if we think about the integers between 1 to 10, we can see when x is equal to 1, then 2 into 1 is equal to 2, which is less than 7. Again, if x is equal to 3, then 2 into 3 is equal to 6, which is again less than 7. But if x is equal to 4, then 2 into 4 is equal to 8, which is definitely greater than 7. Like this, if x is equal to 5 or 6, then 2 into 5 or 2 into 6 is equal to 10 or 12, which are definitely greater than 7. So we can say set A is equal to 4, 5, 6, 7, 8, 9, 10. Since set U contains the elements between 1 to 10. After that, the elements of set A prime. A prime is complement set of set A. Set U contains the complements 1 to 10. So we can say the elements that don't exist in set A but present in universal set U, actually these elements formed the complement set A prime. So A prime is equal to 1, 2, 3 because these three elements don't exist in set A. After that, we will solve the elements of set B and B prime. According to our question, we know that B is equal to x such that thrice x less than 20. Now, if we think about the integer x, when x is equal to 1, then 3 into 1 is equal to 3, which is less than 20. If x is equal to 6, then 3 into 6 is equal to 18, which is again less than 20. But if x is equal to 7 or x is equal to 8, then 3 into 7 is equal to 21 or 3 into 8 is equal to 24, which are definitely greater than 20. So we can say set B is equal to 1, 2, 3, 4, 5, 6 because the multiplication of 3 with these elements given results less than 20. After that, the elements of set B prime. B prime is complement set of set B. So we can say the elements that don't exist in set B but present in universal set U, actually these elements comprised of set B prime. So B prime is equal to 7, 8, 9, 10 because 7, 8, 9, 10 don't exist in set B. There are three statements in example 1 which we will solve now whether these statements are true or false. First one is A prime is subset of set B. From our solution we know that set A prime contains the elements 1, 2, 3 and Set B contains the elements 1, 2, 3, 4, 5, 6. Hence, all elements of set A prime are present in set B. So, set A prime is subset of set B is obviously a true statement. After that, the statement is set B prime is not subset of set A. From our solution, we know that set B prime contains the elements 7, 8, 9, 10 and set A has elements 4, 5, 6, 7, 8, 9, 10. Since all elements of set B prime are present in set A, so we can say set B prime is obviously a subset of set A. So the statement set B prime is not subset of set A is obviously false. After that, the statement is A is not subset of set B. According to our question, we know that set A has the elements 4, 5, 6, 7, 8, 9, 10 and set B has the elements 1, 2, 3, 4, 5, 6. If we notice carefully to the elements of set A and B, we can see 3 elements are present in set A which are actually absent in set B. Again, there are 3 elements are present in set B which are not present in set A. So we can say set A is not subset of set B. So this is a true statement that A is not subset of set B. The question of first activity is given that U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Express the following sets in roster method. First one is set A. A is equal to x such that 5x greater than 37. Second one is set B. B is equal to x such that x plus 5 less than 12. Third one is set C. Set C is equal to x such that twice x greater than 6 less than 17. And the last one is set D. Set D is equal to x such that x square less than 37. Here in this question, set U is an universal set, and in case of this universal set, we have to solve the elements of these 4 sets A, B, C and D. At first, we will solve the elements of set A. According to our question, we know that set A is equal to x such that 5x greater than 37. Here, x is a natural number or x is a counting number. If we think that x is equal to 1, then 5 into 1 is equal to 5, which is less than 37. Again, if x is equal to 5, then 5 into 5 is equal to 25, which is less than 37. Again, if x is equal to 8, then 5 into 8 is equal to 40, which is greater than 37. And like this, if x is equal to 9 or 10, then 5 into 9 is equal to 45 or 5 into 10 is equal to 50, which are definitely greater than 37. So, the expression of set A in roster method will be 8, 9, 10. After that, we will solve the elements of set B. According to our question, set B is equal to x such that x plus 5 less than 12. If x is equal to 1, then 1 plus 5 is equal to 6, which is less than 12. Again, if x is equal to 6, then 6 plus 5 is equal to 11, which is less than 12. But if x is equal to 7, then 7 plus 5 is equal to 12, which is not less than 12 but equal to 12. So, we can say the elements of set B is equal to 1, 2, 3, 4, 5. After that, the set is C, and according to our question, we know that set C is equal to x such that twice x greater than 6 less than 17. Here now we can, if we can think about the element x. If x is equal to 3, then 2 into 3 is equal to 6, which is not greater than 6 but equal to 6. If x is equal to 8, then 2 into 8 is equal to 16, which is greater than 6 and less than 17, which fulfills the condition of set C. If x is equal to 9, then 2 into 9 equal to 18, which is greater than 6 and 17 too. So, in my today's discussion, we can say set C is equal to 4, 5, 6, 7, 8. This was my today's video. In my today's video, I didn't solve set D. Hope that you all will be capable to solve set D according to my today's discussion. And in my next note video, I will add the solution of set D, inshallah. In my next higher mathematics video, I will complete first activity from your textbook. In my today's video, I have tried to make you clear about the set, about the mathematics of set actually. And see you again in my next higher mathematics video, inshallah. Till then, Khuda Hafiz.